Thank you for coming to our Seasteading Social. We usually record these presentations and post them on our YouTube channel, so just so you're aware. Presentations usually last 20 to 30 minutes, and then we open it up for conversation. If you want to ask a question, you can put it in the chat, but we're a small enough group, usually you can just unmute yourself and speak if you're comfortable with that as well. So I'm going to start recording too. We always have backup. Okay. Okay, so today we have Charlie Deist and Rudolph Behrens, who are developing a robot that collects algae from the ocean, an autonomous vehicle. So I won't spend too much time on a bio, so go ahead, Charlie and Rudy, take it away, introduce yourselves and show off your robot.
Go ahead, Charlie.
Right, sure, yeah, thanks, Carly. So my name is Charlie Deist. I worked for the Seasteading Institute from 2011 to 2014, after which I decided I wanted to get my hands dirty, get my feet wet, whatever metaphor you prefer, with sailing, and so I started to sail. Now I'm a Coast Guard licensed captain, still live in Berkeley in the Bay Area in California, and while I was at the Seasteading Institute, I linked up with Rudy, who had this fascinating concept that we're going to be talking about. I'm going to give a quick little introduction and then let Rudy sort of introduce himself and go into a little more depth on the actual technology behind the robot and behind what he's been up to lately. And then I look forward to this discussion where we can answer more of your guys' questions and maybe see how some of you might fit into the longer term vision of how we go from this this prototype that Rudy designed and built. And by the way, I wanted to see. I'm curious to know kind of where people are coming from. So if you want to type in the chat where you are located geographically, I'm curious. So go pop that into the chat, and I'll just continue on here. So I came to be fascinated with this concept of the Algae Biofuel robot, and I want to talk about it as sort of a seasteading business model par excellence, and in particular talk about the timing. Three things about the timing. First is why I think that this is really the right time to make this happen, scaling up from the pond prototype that's already been built, designed, tested. And second, talk about why this hasn't happened before. I think that's always kind of an elephant in the room of, if it's such a good idea, why didn't someone else do it? And then finally, how we can scale it up to advance the big picture of seasteading. So why is this the time to make it happen? First, I think when it comes to seasteading, now is always the time for action. It's always really easy for us to set our sights on the long-term vision and then kind of say, let's let other people figure out how to make it financially feasible. And before the seasteading movement under the Seasteading Institute, it was always just sort of the stuff of dreams. And I tend to be a little bit critical of what I call seasteading porn. You know what I'm talking about. It's these big 3D renderings of beautiful cities where it's missing a sort of small-scale prototype. Now with ocean builders and whatnot, we're starting to get closer to that seastead prototype. But there's also the sense in which we can't pour new wine into old wineskins. And I'm using this metaphor to refer to kind of the infrastructure and the methods that we're using to design and the materials, the supplies, including energy. It's not going to be the same infrastructure that led to the creation of cities of the 20th century. But there are still some things that we want to take with us. Liquid fuel is one of the things we want to take with us from talking about, not wanting to put old wine into new wineskins. But there are some things that are particularly useful, like liquid fuel. Liquid fuel is much more energy dense than any of the alternatives. Like, you think of batteries, even with electrical cars and the advances in batteries, it still doesn't even come close in terms of the joules to weight ratio. So if you want to move big things around, if you want to operate heavy machinery, whether it's moving boats or airplanes, you still need some kind of liquid fuel. But the trick with this is, how do you produce it in an environmentally and financially sort of long-term sustainable way? the oil industry, I think, is not going to be powering seasteads hundreds of years into the future. And so we're left with this problem of biofuels, which has been a pretty tough nut to crack. Biofuels typically require either a whole lot of energy inputs, a lot of land, or highly intensive capital. And so the combination of these three things is basically putting you up against a wall in terms of entropy. It's, you're trying to get more energy out of a system than you're putting in. And these are all three of these things are areas where an autonomous robot on the ocean is getting an advantage. This is why you have things like the Navy paying $424 a gallon for algae biofuel. You've got your solar inputs if you're growing corn for ethanol. Actually, if you'll excuse me for 1 second, I do want to pull up my notes if possible. I'm trying to fly by faith, not by sight here, but if it's so when I hold on. If I go here, now can you guys see, did that just change slides?
We see the Navy Vice article.
It's still the Navy Vice article, huh? Well, and I guess I'm stuck with what I've got. All right, here we go. How about now?
Yes.
Yes.
All right, another way to approach the problem of renewable energy in general is to think of places where, we've all heard of how the cost of solar and wind has come down, but it still faces this problem of being remote and intermittent. It's far away and it only is useful when the wind is blowing or when the sun is shining. So again, it doesn't have the advantages of something like a liquid fuel. In the case of the robot, we're actually using algae as the middleman to use the energy when it's available, using a process to convert the algae into a storable and dispatchable form of fuel, which is the synthetic biofuel that's a byproduct of this process, or I should say it's the product itself. If we're talking about the robot as a solution to algae biofuel or as a solution to harmful algae blooms, then it becomes, you can sort of think of it as a byproduct. But in the long-term vision, this is really a way to power seasteads. Last year, I had a group that was embarking on the next stage of this as sort of a DIY revolution, trying to get, take the, it's basically, simple parts, simple robotics that can be used to square the circle of this problem of either the expensive inputs for biofuels or the intermittency of renewables. And again, with that system for converting algae into fuel as the kind of heart of that system that connects the mismatch that would otherwise be there between when the energy is available and when you want to use it. And this was part of the plans that are still in progress. We want to enable people to actually be able to build these themselves. They're a small enough scale that a single owner operator could be producing for themselves, and also going into their local environment and starting to alleviate this problem, which is sort of the segue into, I want to bring Rudy on here pretty soon to talk about these harmful algae blooms. This was a picture that I took out in the Delta last year. Some of you guys might have been out there for ephemeral, or if you haven't, then you might be planning to come sometime in the future. You get these, dense clumps of algae, which are not only ugly and not only smell bad and make swimming impossible, but they're toxic, and they are taking more and more casualties. Mostly dogs and such so far, but people are starting to actually die from these toxic algae blooms, and the fishing industries, all kinds of industries have become casualties as these blooms have grown. When I first connected with Rudy, algae blooms were not such a pressing problem, but in the time since then, they've really sprouted up all across the country, and I'm sure all around the world.
Why is that?
Well, I'm going to pass it over to Rudy to talk about that next, and to talk about where he is with the project, some exciting things that are happening in Florida. So Rudy, I'll hand it off to you.
Okay. Well, let's start. Who just gave the question of why there's more of them?
I did, Mike McCarthy in Florida, where we had the problem.
Oh, okay. Well, what's changed is the concentration of CO2 in the atmosphere allows a higher concentration of CO2 in the water column because of partial pressures. See, algae blooms only occur when three conditions occur simultaneously. You have nutrients present, basically a biomass. You have, excuse me, 200-foot candles of light in the water column from the surface down to about 4 feet. And you have micro bubbles of CO2 in the water column that are 60% the diameter of the algae cell or less. As the partial pressures of CO2 increase, the times when this condition occurs more frequently. And once that happens, the algae doubles in mass every 20, 30 minutes. So instead of just growing, it becomes a bloom. And the thing about algae is it's a communal organism. So when it becomes very dense, it actually begins to behave as a multicellular plant. Certain algae cells specialize. And one of the things they do is emit a toxin into the water to kill zooplankton, little insect larvae, things like that, because cyanobacteria actually extract the carbon from any organic molecule they come across. So they feed themselves. And that's why there's a sudden increase. But as for the robots, they're based on a principle that I call C3, which means communal coexistence and coevolution. Robots are meant to act as a part of the ecosystem, behaving like megafauna, trimming back the algae in the water to a manageable level because you don't want to eliminate it. It's the base of the food chain, but you don't want the bloom. So what the robots do is reduce the algae on the surface. They aerate the water column, slowing down the growth. And then in the meantime, they convert the biomass of the algae into alkane chains, which have a commercial value. And thus you're paying for your remediation program. Because basically what Florida, in your case, is doing right now is they're appropriating millions of dollars for companies to suck it up and put it on a truck, and then they bury it somewhere, usually a landfill in Alabama or Mississippi. But that's not a sustainable problem. I mean, it's a solution to the problem. So what the robots do is they suck it up and using ultracavitation, subject the algae to supercritical pressures and temperatures, which turns the biomass into alkane chains. But cavitation is an adiabatic process. It's thermodynamically reversible. So other than loss of energy through chemical reformation and radiance, you recover almost all the energy you put into it. So your overall power consumption is very low, which is why wind and solar can power the process.
Where's that being used?
Excuse me?
Where's that being used?
Well, we have our prototype operating in Pennsylvania. We have one operating in Connecticut. We were just evaluated at Moat Labs in Sarasota, Florida, as a remediation method for red tides. And we were the only process that had any effect at all. And
Wow.
at the moment, I'm working with Florida Atlantic University to build 20 robots to operate in Lake Okeechobee.
Excellent.
First commercial operation. We just received all the permits from the Florida DEP to do the work and have a commercial operation.
Glad to hear.
And so the way it's going to work is the alkanes are basically a paraffinic olefin like beeswax, which has a commercial value because it's used in food processing, cosmetics, pharmaceuticals, all sorts of things. And right now it's actually worth around $8 to $9 a gallon, more than it would be as a fuel. So the plan is to collect the paraffins and sell them through brokers and use that to build more robots and run the operation.
Very interesting.
And so we're going to be working out of a rented building in Pahokee, and the city's working with us. Apparently the city owns the building, and they're working with us to make it a permanent operation. see, the thing, what's been happening so far is it's politically expedient to think of an algae bloom in the same sense as an overturned tractor trailer on the interstate. Somebody screwed up, we're going to vacuum it up and hope it doesn't happen again. But that's not how it works. It's become the new normal. So you're going to have blooms all the time and more often and bigger. And so you can't keep treating it just as an anomaly. And that's what our design was actually designed to do. I mean, the robot was meant to be low cost, easily deployable, non-intrusive into the environment, all of these things. So it can be done on a sustained basis.
I don't want to interrupt. Is it okay to ask a question from the chat?
I think we should just get into free form at this point.
Okay, great. So the question is from Steve Lowery. How much of this apparent increase in algae blooms is from improvements in recording and reporting data? To what extent is this already happening, but it's only now that people are really studying and trying to fix this problem?
I'm going to have to say that it's a real problem. It's not just people are noticing it more. Pond scum's kind of hard to miss. And there's been pond scum before. But to give you an example, 3 years ago on Lake Okeechobee, they told me that they had an algae bloom on the lake that covered over 200 square miles. And they emphasized it's not that there was algae blooms over 200 square miles, it was one continuous organism that covered 200 square miles. Just one big lump of green. If you've ever seen an algae bloom fully formed, it starts to look like a leaf. Certain algae cells store lipids and sugars, while others do the metabolizing. It resembles a leaf. It becomes it's the beginning of a multicellular organism, but the toxins are how it feeds itself. It's killing off the larvae, insect larvae and so on in the lake and absorbing the carbon right out of it. It's an amazingly aggressive organism. And the other thing that's changed is an invasive species called Azolla has created a symbiosis with cyanobacteria and duckweed. And the three of them together extend the season and habitable range of the other two. So basically they spread everywhere now. For example, the Azolla allows the cyanobacteria to live through the winter. The duckweed keeps grooming back proteins out of the water column, allowing the Azolla to flourish and the cyanobacteria. And duckweed is an even more aggressive plant. It actually reproduces 3 different ways. So it spreads. And the thing is, it's called duckweed for a reason. Waterfowl love it. It survives very easily in their digestion. And as they migrate, they bring it to new places. So what you're going to see very often is this bloom that's simultaneously cyanobacteria, Azolla, and duckweed all growing together.
Now, was this
man-made? Into the winter.
Is this problem man-made?
The problem, you can call it man-made in the sense somebody started selling Azolla for aquariums back in the 1920s, and it got out into the environment.
Wonderful.
It had the effect of allowing cyanobacteria to get CO2 out of the atmosphere, because the cyanobacteria live inside the Azolla, which is a multicellular plant that gets its CO2 from the air. So that removed one of the limitations on the algae.
I'd like to kind of ask a question to steer the conversation in a certain direction, which will get a little bit more into your background, Rudy, as an aerospace engineer, working in nuclear facilities with large pumps and things like that. But when we look at the design of the robot, it's made from mostly off-the-shelf parts with a few custom parts, including the nozzle, which you can talk a little bit about at the heart of the processing system. But what are some of the principles that you used in designing the robot in order to be, and how does that sort of stem from your philosophy around how this technology should proliferate?
Okay, well, first of all, we followed the rule of aeronautics, which is you'd sell your mother to save a pound. The lighter it is, the less energy it needs. So you might notice the structure is it's what's called it's a tensegrity structure. It's objects under pure tension and pure compression. It's extremely strong, but really doesn't weigh very much. So that means we have less energy to move it around the lake, and which have more energy available to run the process. The other is it has to live on the same energy budget as the ecosystem. The sun and wind that the lake gets is what the robot gets. We don't bring any fuel in from anywhere. It doesn't charge itself from a receptacle overnight or anything like that. It's a synthetic organism in that ecosystem. And the cavitation is an adiabatic process. I mean, it's reversible. I mean, it's about as efficient as you can get for converting, one object into another. So that's where it comes from.
And it's also, I can attest to the fact that the frame itself and the processing unit are not particularly difficult to build yourself using parts that are available at places like Home Depot, Lowe's, tools from Harbor Freight. You can build the small scale prototype for a couple $1,000s maybe. The electronics, I'm still sort of making my way through, plodding my way through, with help occasionally from my wife, who's the physicist and the more electrically oriented. What would you say? I don't know. But even the robotics themselves are not particularly advanced. What's going on inside the
robot? The AI for the robot is a simple analog neural net with just old school transistors and diodes and things.
You have any pictures?
I've got a video here that I think I can pull up with the screen share. Can you guys see this? So this is the pond in Pennsylvania. You see it's moving one way, it's moving backwards. There's a little vertical axis wind turbine on the back, and it's equipped with a couple of thrusters, which are basically just bilge pumps wired up to the solar panel and the wind turbine. Now it's moving a little bit forward. It's thrusting in a particular direction, and it also has that neural net is to guide it into the areas, depending on, I guess, what kind of environment it's in. If it's in a pond, it might be looking for the areas with the most algae. If it's on the ocean, it might be looking for the areas with the most wind, or maybe a hybrid of all of the above.
Wow.
Yeah, the robots actually find the algae. They have sensors that pick up the specific green of photosynthesis and move towards the strongest source of that. Not very sophisticated, but it gets the job done. The robot you just saw in the video was hit by lightning, and it kept working. The only damage it had was one relay was burned, so it lost one thruster. But even then, by the time I got around to fixing it, it had already figured out that 3 left turns equal a right, so it was still working, albeit
forgive me.
So slowly.
What is this unit doing when it's out there? It's finding the algae. What does it do?
Then it sucks it in and passes it through the processing system where it's subjected to cavitation. The biomass becomes an alkane, and the rest is collected in a separation tank. We use a cyclone separator, very simple cyclone separator. And then the residual biomass is returned to the ecosystem.
Did you invent this?
You don't want to destroy it.
Did you invent this?
Yes.
Fantastic.
Yeah.
So we have a few questions from the chat. Are you looking to set up operations in places besides Florida?
We can do it everywhere. We've set up the organization as a Mondragon cooperative. Basically, anybody who wants to make them, I will send them the plans and make them. And the agreement is that if you're just doing it in the public good, have fun. If you do any commercial operations, we're asking for a very small royalty fee from the commercial side. When I say small, I mean 3%.
So I'm putting on
Because
my
this is a huge
FAU hat.
problem. It's worldwide. Any idea of, creating the, the Microsoft of pond scum is absurd.
Michael, you were flashing some FAU swag there. What's your connection?
There you go. Yeah, well, I've taken a course through there, and of course, they're not far from me, so I think it's a great school.
Yeah, well, they have a, excuse me, they have a marine robotics engineering major, and those are the students that are going to be building the robots for us.
Oh, okay. Do you come down here to visit?
I will. I haven't yet, but I'm planning on it. I've had some things I couldn't travel. I was getting some therapy, but I will be coming down very soon.
I'd love to meet you.
Well, we'll hook up.
Great.
I'm going to be spending time between the FAU campus, Pahokee, and Sarasota.
Okay.
So
I can make Pahokee. Sarasota's a little far from where I'm at.
where are you?
West Palm Beach.
Oh, well, that's where FAU is, right?
Correct.
Yeah. So,
Well, they're actually
maybe hook up over there.
Yeah. Okay, great.
No use driving out to Pahokee. I understand it's kind of remote.
Yeah, it is. It is.
So I have
I
another
had
question.
to pull the Zoom way back to even see the next town. So yeah.
I have a few more questions from the chat. From Shannon, how does your system compare with saltwater-based method for producing biofuel from algae? How is the industry set up currently? Is more algae seaweed being harvested from farms or from naturally occurring threats? And is there enough material naturally occurring to sustain a market long-term?
Well, that's a lot of questions. We've tested our process in freshwater and saltwater, and it's definitely more efficient than anything that people are doing right now. And there's more than enough sargassum for a commercial operation. That's actually spreading too now. It's the basically it's the pond scum of the ocean.
Well, I thought sargassum were large pieces of seaweed. Am I incorrect?
But it's an algae. It's a macroalgae.
Okay. So it can't be broken down into, would you have to like scale up your robot to get sargassum, or? No,
the only reason we would scale it up some is because of it function of wave height. You need pontoons on it long enough to span 2 wave crests, so it doesn't spend all its time bobbing up and down. So for the ocean, they're going to be about twice as long as the ones in freshwater, but that's still not very big. I mean, we're talking about 40, 45 feet long. We don't need a aircraft carrier to go do it. But they just have to be big enough to be more or less stable.
So what would you do with the sargassum when you're there with the robot? What does it do?
Do the same thing, suck it up, pass it through the process. Algae is algae.
Dense stuff. That's pretty dense stuff, the sargassum.
I'm sorry, I didn't hear you, sir.
It's pretty dense.
It has no lignins in it, though.
Okay.
It'll crush. We've crushed it. It crushes.
Okay. What kind of pumps do you need for that kind of power?
Same kind, high pressure, same kind of high pressure pumps.
Just more horsepower.
Just more horsepower.
More PSIs.
Yeah. It's fairly standard equipment. I mean, it's not standard in the sense that some people would know, would have it in their home, but it's fairly common industrial type equipment. Not hard to come by.
So another question from Steve, does your team have any plans to work with the Arctide group? And I think we have, is Dan still here from Arctide? Or Ben? They're based in Florida. They're working on harvesting sargassum.
I'm here.
No, we never met with them. Did you, Charlie?
Is that Mike Doty?
Yeah, this is Mike Doty. Ben was here earlier. Maybe he's dropped off since then. So, yeah, so very
Mike,
interested.
how are you?
Oh, great. Good to see you again.
Likewise.
It looks like you're on your boat there.
Indeed.
Very cool.
As far as
Well,
answering their question, I've never met with them before, but it sounds like, it might be worth talking to. So if they can get their contact information from this, then, love to hear from them.
So-
Yeah, I'm very interested in how you're doing this cavitation and processing and applying it, being able to apply it to sargassum to actually. Yeah, so I'm looking at different
Who's
methods. as far
speaking
as-
now?
This is Mike Doty,
Oh, well, what?
also in Florida. Mike, you're located where in Florida?
I'm in Orlando. Ben's over in Tampa, which is where we're based out of.
And are you with Arctide? And can you tell us a bit more about what you guys do?
Yes, so we are working on building the platforms out of concrete, using a high performance concrete, and also to be able to use those platforms to harvest sargassum and do marine polyculture, materials extraction out of the ocean. So yeah, the sargassum is kind of more my end. Ben's handling more of the building the platforms and the concrete and
Well, what our robots do is they suck it up, and in addition to the high pressure pump for the process, before that, there's a macerating pump that chews it up.
Okay.
And that's fed into the process pump.
And then this
She mixed
cavitator,
her.
is it kind of like a Venturi kind of device you're using for the cavitation?
The
Or an impeller,
cavitation is a oddly shaped orifice where the fluid is passed at extremely high velocity, causing it to cavitate, ultracavitate. If you could look inside, you'd actually see that blue-white glow.
Really?
Yeah.
Oh, okay. This sounds interesting. Do you have a
But the
website?
thing is,
Yeah,
once
there's-
it slows down, everything's back to ambient. Inside the cavitation zone, it's 8,000 degrees and 5,000 PSI. But after that, it's back to ambient conditions. It's reversible.
I just put a link in the chat to the media and video page of your website, Rudy, which has a video about cavitation from the BBC, and it's looking at a pistol shrimp in particular, which, if you've ever seen this this humongous claw that snaps down and sends out a bubble that then collapses, and inside that bubble, when it's collapsing, it's temperatures and pressures like as hot as the sun or something like that,
Yeah.
and it kills its opponent through, or it's either predators or prey. But check out that video. I would play it, but I don't want to take up
It's kind of a long
time.
one.
It's about
but it's
watch the whole
excellent.
thing.
It's one of the best videos I've ever seen explaining how cavitation works.
I'll put the YouTube link just directly in the chat too, if you want to go straight there.
Oh, sure. Yeah, the thing about cavitation is it's an extremely common phenomenon, but it's also not commonly understood.
Yeah, I mean,
Cavitation actually destroys metal an atom at a time.
That's where I first saw it. They were studying it. It was a pump impeller on the space shuttle. They were studying
yeah.
it. It was
Yeah, I
like
mean-
stroboscope to watch the bubbles.
They had a situation, something like our process at a nuclear power plant, that milled off metal out of one of the pipe elbows until it blew out. Just kept, machining away the metal, making it thinner and thinner.
So in that case, it was a defect of the process, not a feature.
It was an accident of the process.
But it can be used to make nano bubbles, as interestingly enough, which have some use.
No, not really. It's making cavitation bubbles.
Oh, okay.
There's no
difference?
bubbles left. It's not the same as getting a gas out of a liquid. It's the liquid changing state to a gas temporarily.
Oh, okay. Does it turn into plasma even, or just a
Yes,
gas?
it does.
Oh,
In fact,
okay.
as the bubbles collapse, they are momentarily a solid, crystalline solid. That's when they throw
Crystalline.
off an electron.
Oh, okay. You have to read up on this. It's fascinating. So in your case, you're using it to reduce the biomass into olefins?
Yeah, what it does is the proteins of the algae go into this zone. Basically, they're blasted into a plasma, into their elements. And then as it reverses again and cools down, reassembles in a lower energy state, which is basically hydrocarbon chains, water, and carbon dioxide.
Okay.
So the
Because
water and carbon dioxide pass away, and then you're left with an alkane chain.
Mhm. Okay, I see a picture up now. Is that?
Yeah.
I just saw your duckweed and azolla briefly flash by there.
Well, it's not mine. It's yours too, if you want it.
Okay. Yeah, I
See, the
hadn't
thing
heard
is,
of them
using this as a
coexisting.
feedstock is unique, and because if you have a gallon of pond scum, you wait an hour, you have 2 gallons.
Yeah, the doubling rate is amazing on those
Oh
things.
yeah, it's we ran a test in controlled conditions at Rutgers University Marine Lab. The biomass was doubling consistently every 90 minutes.
Wow. Wow. So what's the object of doing all of this? I mean, I love what you're talking about. It's fantastic. It's highly technical in some areas that I don't understand, but you've tried to break it down into simple terms. But the point is, are you going to try to, how many of these units would have to be built to control, you know, like the sargassum, the algae, or you know, where are we going?
Let's start with Lake Okeechobee. We're starting with 20 of the small robots because that gives us 5,000 gallons a month of saleable product,
Okay.
which is the minimum you need to wholesale petrochemicals or any kind of chemicals.
Okay.
To bring Lake Okeechobee under control would take about 2,000 robots.
Yeah.
But the thing is, we don't have to build them ourselves. We'd be glad to let 2,000 private individuals build one in their driveway.
Yeah, it might
Yeah.
be good for a tokenized adopt a robot program. Even.
Well, I mean, it really is quite doable. The robot's 10 feet long, 5 feet wide. It fits in a pickup truck.
Wow.
The one for sargassum has to be bigger because it's in the ocean, but even then, it's not all that much bigger.
What about
Oh,
size now? You're talking,
I'm sorry?
You're talking about the size of the units. Couldn't you just build them bigger for Lake Okeechobee? I mean, like huge.
You could, there's no advantage to it.
Okay, thank you.
Yeah, you actually are more productive to have a bunch of small ones skittering around than one big one.
Okay, thank you.
See, once you get past 20, 30 feet long, you need a shipyard and a crane to get them in the water. The
Right.
ones that we're making, you only need is 2 guys with some boots, and you walk it into the water.
Okay.
I have a couple questions from Shannon and Luis. What does the robot do with wastewater discharge? And can you speak to the bioavailability of the effluent created as a result of this process?
It discharges back into the water column, and what's in there is just chlorophyll and water. It's not chemically changed at all. All that happened is some of the proteins in the cell became alkanes, basically beeswax, and some carbon dioxide and some water was released.
Okay, I'm very interested in all this. I bet everybody here that's listening is. Now, I'd like to ask, how does this relate to seasteading?
Great question, and that's kind of the third question from my introduction of what's next, and where does it go beyond inland waters and things like that. I made the decision, I guess it was about 8 years ago or so, that I wanted to get my bearings by actually starting to understand the waterways near me better. That the best way to become a seasteader was by actually getting out on the water and sailing and doing things like that. Ephemerisle is a good opportunity to see what it's like to spend a week on the water, even though it's not quite as intense or remote as going out on the ocean. And I think for me, there's a lot that can be done within inland waters, whether it's a river delta, a lake, or even just a pond, to start to make this technology. I think there will be I won't say necessarily a long stage, but I think that there will be a stage of rapid iteration. We've got the basic design, but people will adapt it to their local environment, and as the technology starts to evolve, people will move into bigger and bigger waters. The model is also, I think, kind of an interesting experiment in the economic philosophy of distributism, which doesn't get talked about a lot in seasteading circles, but it's kind of the idea that, you know, we should try to have more widely distributed ownership of the means of production, not government going in and redistributing, but that we would rather see a society where people tended to have a share in the ownership of the means of production, so that people can be more self-sufficient. And I think that this as a foundation for seasteading helps us get to a vision where more people can buy in to the long-term vision of whether floating cities or, you know, dynamic geography. But we can also talk a little bit about the bigger versions, the scaled-up versions, because when I encountered this, Rudy, was, and I think that the earliest patents and designs were centered around an ocean-based system, and the ocean is where you get the majority of your wind. So, Rudy, can you talk a little bit about that and the original patent, that maybe even go into the hydrogen?
Yeah, there's a lot of what they refer to as stranded energy out on the ocean. Wind, sun, wave action produces a lot of power, but how do you use it? Excuse me. So the idea is you use the wind and that to process biomass into synthetic fuels, and then they can be used at sea, on land, wherever. It gives you a marketable product. And I guess the answer to the earlier question of what it has to do with seasteading is it's how you earn a living once you get there. You know, I mean, that's part of the big incentive of wanting to live out there, is you need to earn a living. So this is an opportunity.
And another question from the chat: what permits are needed to operate in U.S. and international waters?
On international waters, you don't need any, because it's licensed as a vessel and it has a certificate of seaworthiness from the U.S. Coast Guard. To operate on inland waterways, it depends on where you're living. Some places, nothing. Some you need. Florida, you needed water. You need to get a permit from the DEP. But it's not that hard to get them, because you're not really discharging anything, and you're not using any chemicals, and you're not putting anything at risk. And even though they're self-propelled robots, they're moving at about 5 knots. So it doesn't exactly make them a projectile. So it's pretty straightforward. The people operating it in Connecticut don't use any permits at all. The Connecticut environmental people said, yeah, you know, go ahead. There's no chemicals, so we don't care.
Very interesting. Yeah, well, good luck with that testing down in Florida here. I mean, it sounds like you may have come up with a really great solution.
Well, it's one of, you know, the problem is so big. I just hope it encourages other people to come up with others, because, you know,
right.
There's a lot of heavy lifting needs to be done to clean up. So
that's for sure.
So another question from Damon: can you use the algae/scum as an inoculant for biochar and then remediate soil?
Yeah, why not? It's a plant, same as any other.
Can you explain what that question means?
Yeah, what's an inoculant? That's my question.
I assume he wants to bake it into a biochar. So that's basically, you're making an activated carbon. And there's certainly a lot of carbon in it.
What about red tide?
Excuse me?
Red tide.
Who was asking that?
Mike McCarthy again in Florida.
Oh, well, we were tested for red tide. We were the only system effective. We not only got rid of the organism, our process destroyed the toxins too.
Wow.
And out of the 17 systems they tested, we're the only one who did anything at all.
So,
But we got rid of the organism and the toxin at the same time.
Damon, did you want to explain
Yeah,
more?
yes, I do. Yeah, I did had my thing on mute, but when I was talking about inoculating biochar, I was thinking about the nutritional value of scum, duckweed, and
They're
the
very high in nutrients.
effective microorganisms. That's what I was after. So I'm assuming these are laced with all kinds of. I want to make biochar. I have a sawmill. I have slab. I'm going to make charcoal, and then I want to inoculate it with the scum. I have a 10-acre lake, and it has a lot
Yeah,
of
that would do
seaweed,
it.
a lot of seaweed and
I
scum.
mean,
in
if
it.
you look at the breakdown of pond scum, you have almost the entire periodic table.
That's what I'm after right there. Okay, great.
So I would recommend that you just find some pond scum and start culturing it.
Well, I'm already culturing it on 10-acre lake, so
Okay, well
I'm
then,
letting nature do that
if
for
you
me.
show it any carbon, the cyanobacteria starts attacking the carbon. It'll make a skin right around it.
Okay.
And Damon, where are you located? I missed it.
I'm in Michigan. I'm sorry. I
Okay.
arrived
Yeah.
late here, but I'm very
I mean,
interested.
if you
in what
have
you're
the
doing.
biochar already, if you feed it to the cyanobacteria, they will eat it.
Oh, yeah. Yeah. Worms will eat it too.
Mhm.
So,
Yeah, it's
okay.
a natural match.
All right. Thanks.
Getting back to sargassum, I passed on some articles to Carly. She may have posted it in the repository for seasteading, but there are some positives they talk about, for birds and stuff like that. So I don't know enough about it. So you're going to basically, the system though, it kind of destroys the sargassum.
No, see, it's what we're doing is we don't want to destroy algae or sargassum or anything. We want to prune it back to a tolerable level
Okay.
because it's all part of the ecosystem. You don't want to destroy the ecosystem. So that's why you don't want to use herbicides or anything. You're destroying the process. We just want to trim it back enough so there's not a bloom anymore. It's the bloom that's harmful, not the organism.
Well, I've read that the sargassum, I mean, if you call them blooms or whatever, I mean, some of them are huge, miles
Yeah.
and miles.
Yes, they are.
Huge.
And if you ate half of it, by the same time tomorrow, it'd be back to the same size.
Jeez.
Yeah, basically the
You
limiting
don't have to worry about using
factors-
up all the pond scum or sargassum. It keeps regenerating. That's the whole thing. You're just trying to keep it scaled back to a tolerable level so you don't get the toxins in the water. Because those are hard. Those are hard to live because they kill fish, they kill birds. It's see, basically the organism has decided it doesn't have enough food, so it's going to start killing animal life to get some. That's really what it's doing.
Wow.
Fortunately, it's not sentient, so we're not in that much danger, but the process still goes on.
Wow.
And
So another
actually,
question
if you go to
from
our
Steve.
website, you can download the plans for the robot. So go right ahead.
So question from Steve, is there any danger in handling the chemical product?
It's basically
Sorry, I think
beeswax. If you remember those wax lips from when you were a kid, same stuff. Chemically, it's the same stuff.
And how is it transported to wholesalers?
It would be shipped on a truck, in a tanker truck. It liquefies at a it turns to a liquid at about 85 degrees Fahrenheit. It'll melt in your hand.
Wow.
So Shannon says, in Texas, we have to have a permit every mile for discharge. Currently working with Congress on this issue for new technology.
Well, you're not really discharging.
So
It's a closed loop.
guys, let us know. We could be in an emergency waiver, possibly.
But you're not
So
really
Shannon, I
discharging.
don't know if, Shannon, if you want to unmute yourself and explain a little bit more.
Hello. Okay, I just unmuted.
Hello.
we do for you?
Tell us what you're doing in Texas.
So we have a project kind of similar, but our vehicle is more focused on CBRN threats. So it's subsea CBRN detection and mitigation. So you guys would kind of be in our bio threat category. So overall, we're looking at chemical, radiological, nuclear threats as well, kind of running a gamut there.
Okay.
So I was just asking for comparison purposes on some of the permitting issues, because this is.
Well, you're detecting these radiation threats and so on. Is that right?
Pardon?
Your process, you're looking for chemical or radioactive threats,
Yes.
and then is it your plan then to remove them?
CBRN is chemical, biological, radiological, nuclear, and
So you're looking to remove them from the environment.
Or process them in a way that is no longer threatening, rather than scooping them up and burying them somewhere in some kind of.
It would be a little different because
it's a bit different. Yeah.
See, what we're doing, the algae is indigenous to that water. You're looking to remove chemicals that were introduced artificially, and then you're concentrating them in the collection process. So they're probably going to make you write a report on how much you made and what you did with it.
Yeah, or it could be I think one of the bigger problems is invasive species on the biological category.
Oh yeah, a lot of those.
Yeah.
But I'm an engineer. I'm not a lawyer or environmental expert. I can give you experience based on what I've done, but if some advice might be beyond me.
Mm-hmm. Well, it's a new technology that's not really out there for CBRN. So we have mitigation tools for land-based CBRN threats, but we don't have anything for water. So that is what we are working on.
Well, it sounds like it's something that we need done, but
yeah, I think probably these robots could actually link up and work together.
Very likely.
Yeah.
Very likely.
Yeah.
You have links to our website, and that has contact information. If you could send me information on how to reach you, maybe we could talk.
Sure. We are at archivalinstitute.com.
Archival.
So you can look us up also.
Okay.
Rudy, do you mind if I pop your email address into the chat along with mine?
Sure, and then my social security number.
Yep, all the above, all that.
Yeah.
All right.
So we have about 5 minutes left in our given time. So if you have a burning question, now is the time to ask. Damon asks, how much does it cost to build one of these robots?
Charlie?
Yeah, so when I am still in the process of assembling all of the electronics for the frame itself. We did it for, I think, probably under $700. A lot of those materials came from a local kind of glorified junkyard called Urban Ore. So I found some 6-inch thick pontoons, just 6-inch thick PVC pipe, and then the most expensive thing was actually the end caps. Those you have to order online, and each of those was like $30. But actually, the seasteading community stepped up and kind of helped sponsor that, and I'm feeling the need to actually deliver on the plans. Which we got about 75% of the way, and then hit some snags with the electronics, and then now we're slowly getting back into it. But I think that probably the total cost for a robot using newly purchased parts might be $1,500 to $2,000.
Yeah, that's
for a
if you
10-foot
purchase
long.
all new material.
And one of the things that Rudy is doing now is you could custom order certain parts from Rudy, including the kinetic nozzle. I think that you're 3D printing the mold for that, and also some of the robotics. What a longer term vision of mine is to kind of come up with the full kit where you can order all of these more specialized parts and sort of pre-assembled electronics and make it a little bit more plug and play.
But there's no trick, no secrets here. If you download the plans for the robot, it includes the plans for the nozzle and the schematic for the robotics and everything. So, and if you're willing to put the time in, you can, there's nothing held back. Just might take more work.
Awesome.
Wow. These things should be mass produced.
Excuse me?
Mass
They should
produced.
be Mass produced.
Well, that would be nice.
Caleb, do you want to unmute yourself and ask your questions about algae biofuel?
Yeah,
how it
sure.
works?
Yeah, of course. Thank you, Carly. And thank you all for giving the talk. Hello from Seattle. I had a few quick questions. One, just a clarification, is algae biofuel a byproduct of the algae pruning, or is it sort of algae biomass that can be converted to biofuel?
No, what it is alkanes. It's paraffinic olefin, C24.
But
Gotcha.
it's the product of conversion. It's the result
It's
of
what's left
conversion.
after the process, yes. We're not squeezing any juice out of the algae.
Okay, gotcha. That makes sense.
Just for an example, I used sugar as the feedstock instead of algae. We got the same results.
Gotcha. Sweet.
Just organic molecules. It doesn't,
Yeah.
there's no compounds unique to the algae.
Gotcha. And then also, are there algae blooms in the open ocean, or are they more kind of a coastal inland phenomenon?
No, they're everywhere. It depends on the conditions.
Gotcha.
Sargassum basically extends from somewhere near the Caribbean almost to the coast of Africa.
Wow. Gotcha.
That's technically an algae bloom.
Mm-hmm. Great. Thank you.
Oh, you're welcome.
But what is that we have to remind ourselves how little we know about the oceans?
Yeah.
It's true. I think that's another argument for starting small and iterating, and undoubtedly unexpected challenges will come up. So the idea of kind of going straight to the ocean, I think is a little bit daunting. But if we can start in some of these smaller environments and figure out what works and what doesn't, then before long we'll be getting out there, and also with more robots on the ocean, those become data points if they're equipped with any sort of sensing modules, things that can give us more data on what's going on.
Sure.
So we have reached the end of our time. Thank you so much. It's been a great discussion. I just want to draw everyone's attention to the chat. We have a feedback form for our seasteading socials. Very short, just a few questions, and I appreciate it. If you want to respond, you can also request topics for future events or volunteer to present if you have a project you'd like to present. And then I also have an Eventbrite link, tentatively planned a cryptocurrency discussion for December 11th. Once I get all of our speakers finalized, and make sure that they can make that date and time, then that will be final. But you can sign up to get notified about that if you RSVP. And if Charlie and Rudy are willing to stick around for a few minutes, if there are any more questions,
Sure.
now's your time to ask.
Yeah, shoot.
I think it's been a pretty robust discussion.
Yeah, it was great to have you. It's slightly different topic than what we've been talking about recently. So it's great to have a wide variety of topics to really fill out what a seasteading society needs. And as Rudy said, how are you going to make money when you're out there? What's going to fuel your boats? What's going to fuel Ocean Builders is building a smart Internet of Things home. So if you want that to have energy, having
And
a
all of these
diverse source.
stockbrokers.
Yeah.
Can all be stockbrokers.
So appreciate everyone for coming, and fill out the feedback form, and hopefully we'll see you next month.
Thanks, Carly.
Thank you. Thank you.
Thanks
for having
everyone for
me.
coming.
Thank-